Hello, everyone. Have you ever seen a monumental statue or any building looking as if it has melted or as if somebody has been breaking small pieces of it? That's often due to acid rain. Today, we're talking about the rain that can burn stone and kill lakes. Sounds dramatic, but it's real. Acid rain is one of the clearest examples of how human energy use affects the whole ecosystem. By the end of this video lecture, you'll be able to explain why your car exhaust can damage a forest as far as 500 kilometers away from you. That's the power of air plus water chemistry. If normal rain is like lemonade, acid rain is like lemon juice concentrate. So let's see what is acid rain. The pH of pure water is 7, which is neutral. Rain often absorbs carbon dioxide from air and forms a weak carbonic acid, H2CO3, and its pH is normally 5.6. This is normal range of rain. It is not due to pollution. But when we add oxides of sulfur and nitrogen, like sulfur dioxide or um, nitrogen dioxide or oxides of nitrogen, we get stronger acids like sulfuric acid or nitric acid. This drops the pH of the rain lower than 5.6, 4 or even lower than that. At pH 4, water is 40 times more acidic than the normal rain. The acid deposition is mainly of two types: wet deposition or dry deposition. When the sulfides of when the sulfuric sorry the oxides of nitrogen or sulfur are mixed with the rain, snow, or fog, or even with hail, they fall off in the form of the wet deposition. But dry deposition are the acidic particles with dust, gas, or other such particles which are dry on settling on such surfaces. So in real life, pH scale is like a staircase. Each step down, it is 10 times more acidic. Normal rain, one step is 5.6, while the next step is acid rain, which is on pH 4, which is 40 times stronger. And lemon juice is step 2. Um, have you ever used any acids in your kitchen, like vinegar, soda, lemon? You must have noticed they are corrosive and they can break um, anything kept in them for longer. They can even dissolve surfaces. So any rain which is not in range of the normal rain pH of 5.6, but it drops to the acidic range of 4, it is called as acid rain. There are certain causes behind the acid rain. Um, Sulfuric acids, basically sulfides of oxides of sulfur, are 70% responsible for acid rain, and they mainly come from the power plants or coal power plants in Pakistan, coal plants at Port Qasim or Sahiwal, and coal mining in Duki, Balochistan. It releases tons of sulfur dioxide, coal, um, old plant material with sulfur trapped inside. When you burn an old plant material which has a trapped sulfur inside it, and when you burn it, it releases that sulfur dioxide into the air that also causes acid rain. The second cause is oxides of nitrogen, which is responsible for 30% of the acid rain all over the world. It is made with air, and nitrogen plus oxygen gets super hot in car engines or jet engines, and they can also be originating from farms or from fertilizers in the farmlands or in the croplands or agricultural lands. Besides these two causes of acid rain, there are some natural sources of acid rain like volcanoes. There is a volcano like Krakatoa. It releases huge sulfur dioxide. Lightning also fixes nitrogen and converts it into oxides of nitrogen. But human sources definitely dominate the natural sources of acid rain. Um, One coal power plant, it releases up to 500,000 sulfur dioxide as compared to that the cars would do. Like if you have 500,000 cars would release as much sulfur dioxide as just one coal power plant would do. That's why when big chimney can affect a whole province. Quetta Valley has temperature inversion in winter. Pollutants get trapped into materials, and then more dry acid deposition. Uh, it can happen in pistachio orchards. So there are some chemical reactions in the atmosphere that are responsible um, for acid rain. Let's see at the full chemistry of formation of these acid rains. Sulfur dioxide is like a shy gas. It meets radicals of OH in air, becomes sulfur trioxide, and then it reacts with water and it becomes sulfuric acid. Same acid in car batteries. On the other hand, nitrogen pathway is like nitrogen dioxide reacts with the OH ion and it forms nitric acids. Both these acids dissolve in cloud water and fall as acid rain or snow. You can think of cloud as a mixing bowl where sulfur dioxide or nitrogen oxides are the ingredients. Sunlight plus water is the recipe for acid rain. There are other contributing gases like carbon dioxide, but we know that it forms very weak acids, which is carbonic acid, and it's not the main cause of acid rain or acidity overall. There are, besides carbonic acids, there are some ammonia, NH3 from fertilizers can also neutralize acid, but also forms ammonium sulfate particles. There is a role of CFCs, the chlorofluorocarbons, which are used in the old ACs or in the refrigerator, even in the spray cans. But CFCs do not have any hydrogen atoms in them. So when they break in air, they cannot form the hydrogen ion or acid ring. So what do? They rise to stratosphere, and UV light breaks the carbon bond from chlorine bond, and it forms a chlorine atom. Now this chlorine atom it can destroy 100,000 ozone molecules, and it causes an ozone hole like the ones in the poles. So these both problems comes from 20th century industrial chemicals, but solutions differ. So the CFCs are not directly responsible for acid rain, but they are definitely responsible for causing holes in the ozone layer. In the figure, you can clearly see what acid rain can do to an ecosystem. Can you see those dead fish and dead plants? Let's see what are the impacts of acid rain on the ecosystem. First of all, let's see what are their effect on the aquatic ecosystem, like lake and rivers. First of all, they give a pH shock. Most fish eggs need pH 6 to 7. Below 5.5, eggshells harden, so the embryos will die inside, the eggs will stop hatching. And adult fish normally die below the pH of the 5, so they cannot survive. There is an aluminum story. Soil has lots of aluminum, but it is locked up at normal pH, while the acid rain unlocks this aluminum like opening a poison box. This aluminum sticks to fish gills, and fish cannot breathe even with oxygen in water. Like plastic, if it is wrapped on your nose, you won't be able to breathe. Just like that, these aluminum that were trapped in the soil particles, when it is released by the acid rain, it can kill the fish because they are unable to breathe. Besides this, the food web is also affected badly. It first of all kills the uh, mayflies, then the amphibians like trout. So they all lose their food, and eagles lose trout, and this effect just multiplies. So this will cause a collapse in the food web because the plants, the planktons, they all cannot survive in lower pH. In 1970s in Sweden, locals call lakes as clear death because water looked clean but it had zero fish in it, like a swimming pool. Looks clean, but there is no life inside it. So this was happening in Sweden in 1970s when the lakes were acidified due to acid rain. All the life in the lakes had disappeared. Um, Hana Lake Koita is naturally alkaline, but small ponds near coal areas show pH drop, and those lakes or ponds has no life inside them. Okay, so beside the aquatic ecosystem, they also have adverse impact on the terrestrial or ecosystem, just like, for example, the forests. What acid do is they leach down the nutrient. Imagine soil as a fridge. Calcium, magnesium, potassium are food. Acid rain is like water leaking in and washing all food out. As a result, all the trees will starve, they will not get any nutrients, and the leaves yellowing occurs, and later in later stages, if this continues and the trees has no food, they may die altogether. So nutrient leaching is a huge impact, bad impact of acid rain on the forest ecosystem. Again, aluminum release in the soil, it blocks root uptake of nutrients, um, and again the damages of the fine roots, which will also impact adversely the water uptake of these roots. There is direct damage like acid fog or rain. It can burn the leaf surface, reduces photosynthesis, and the forest die back. It was seen in the Black Forest in Germany in 1980s. The spruce fir trees had all died, and um, as a result of this, all power plants were um, forced to have scrubbers to control this issue in Germany. It can also adversely impact the soil microbes. Bacteria and fungi that recycle nutrients become less active at very low pH. Because low pH does not favor the working for recycling of the nutrients. A direct impact of the acid rain on ecosystem is the loss of biodiversity. Amphibians, which are very sensitive because their skin absorb acids directly, they may die. Besides that, plants are also very sensitive to pH. Only certain plants that can tolerate acids, they may survive. This will eventually result into loss of most of the biodiversity, and only few resistant plants or animals would be surviving in those areas. And as it is disturbing the normal ecosystem, this will eventually cause in the death of the ecosystem. But there is always solution to certain these issues, and we should look for those solutions later on. The humans are also actually affected adversely, like the buildings that we build, they are affected, like corrosion by calcium carbonate in marble limestones. with sulfuric acid turns into calcium sulfate plus carbon dioxide plus water. So old buildings like Taj Mahal or statues, even bridges, they deteriorate, and this condition is very popularly known as stone cancer. In this, you can see broken or small like cracks, even small uneven surfaces on the stone, the marble stone. Besides the structures, human health is also adversely impacted by the acid rain. It does not burn skin directly if it comes in contact, but it can cause asthma, bronchitis, or issues like lung cancer in very um, peak and adverse cases. In Pakistan or Balochistan context, Balochistan is arid and the air is very, very dry. So the coal mining in areas around Quetta, Chamlang, Duki, these coal power plants and the exhaust from vehicles that release sulfur dioxide and oxides of nitrogen actually can cause dry depositions. So in the local impacts will be the uh, date palms, pistachio orchards, which are sensitive to soil acidification. This dry climate of Quetta mean there will be more dry deposition than acid rain. So now let's see how we can control this issue. We can actually stop this at source, like reduce the emissions, or scrubbers can be installed in the power plants, and flue gas desulfurization, like this is the um, equation again for calcium carbonate plus sulfur dioxide can make calcium sulfate plus gypsum, or which is gypsum. It removes 90% of sulfur dioxide from power plants. So this is example of scrubbers. Catalytic converter in vehicles can convert oxides of nitrogen to nitrogen plus water. We can also shift to clean energy, to solar energy, wind energy, natural gas instead of coal. Um, if we shift to the wind energy, like solar energy, this can actually um, reduce the emission of these harmful gases in the atmosphere. Um, in Sweden, like 200,000 tons of limestone powder is added to lakes to actually remove the acidification. It neutralizes the acid in the lake, and which is known as an antacid for lakes. It is costly, but it is better to um, reduce the source. In the figure, you can see that the death of the lake is happening in the red, the top one is just showing a red, everything is red, and you can see two men sitting in a small ship. They actually are adding the calcium carbonate or CaO to water in the bottom two, you can see that eventually the acid is neutralized and the fish are actually smiling and they're happy. So this kind of solution can be done, but not all the countries can actually afford this kind of lake neutralization. So it is better to stop the problem at its source. In Balochistan, there is low rainfall, high dust, so there is dry deposition, which is a bigger problem than rain, because dust particles with sulfate or nitrate, they settle on the leaves and soil, and when rain comes, it becomes extra acidic. So the impact will be on all the orchards in Balochistan, like there are pistachio orchards, or which is a gold crop of Balochistan, and its roots are very sensitive to aluminum toxicity, which happens due to acid rain. The coal dust plus vehicle nitrogen oxides near Koida city roads will reduce the yield of pistachio finally. As a student, you should see what you can do to solve this issue. At governmental level, there are solutions and control measures by local as well as international law and policies implementation, like the Clean Air Act in the US, which was in the 1990s, cap and trade for sulfur dioxide, and 80% of reduction since 1990. UNECE Convention on Long-Range Transboundary Air Pollution in 1979, and Europe cooperated because these acid rain actually crosses boundaries. It it can, because it is the mainly the reason behind the acid rains is the air pollution. So that is why air pollution just can travel across the boundaries of a country, from one country to the other country, so it can travel to the long regions. So that is why, to control this issue through policies and international laws are needed, or treaties are needed, to which all the countries should sign and they should follow. So thank you so much. That's it for this lecture. If there are any questions, you may ask and in the comments, and I will be responding.